All right, it is 9 o'clock. We are going to go ahead and get started here real quick. My name is James Renwick. I am the Training and Development Manager here at Johnstone Orion Group. I am extraordinarily honored to be joined by Ron Vogl and Eric Dillon. Ron is one of the top trainers over at Honeywell. Eric is our master trainer here at the Johnstone Supply Training Center. We are going to go over a ton of stuff today on the A2Ls front. I do want to start here. If you guys have your phones out, you've got two different QR codes up in front of you. What those are for, the one on the left is the training schedule that will forever be updating. It is the training schedule for all of the trainings we run here at the Johnstone Supply Training Center. That includes both trainings at in our shop, and it includes trainings. Oh, Esri, you're being so funny now. It includes trainings at our shop and things like this webinar here. Over on the right side, you will see another QR code. That is to request private training. If you want us to come out to your shop and deliver the A2Ls training or any of the other trainings we run, our electrical trainings, we have maintenance trainings. We've got a ton of stuff here, EPA, stuff like that. If you want us to come out to your shop and do it for all your techs in one fell swoop, we can make that happen. So you can request the training there. Our next scheduled A2Ls testing and training class, which does lead to the ESCO certification, as part of that training, the ESCO certification, we give you that test in the class. That is coming up May 10th. It is 8 a.m. to 4 p.m. You get trained on the A2Ls. You will get a copy of the A2Ls Low GWP book from ESCO, and then we offer you as many as 2 chances to pass that A2Ls test. We're currently running at just a hair over a 90% pass rate for that class. So if you guys are interested, when you click on that training schedule, you'll see it in, like I said, on May 10th. Be able to register right then and there. That is all I've got for you guys. I'm going to turn it over to the experts now. Ron and Eric are your guys here. They're going to have all the good stuff for you. Ron, you can go ahead and take back over, share that screen, and you can get us started.
All right. Let me know when my screen comes up. Am I audio?
Yep. Yes.
Okay.
Audio is good. Still waiting on the share. And there you go. You're off to the races, sir.
Great. Thanks, Jane. Appreciate it. Eric, thank you very much. Ron Vogl, Honeywell Refrigerants. Been with Honeywell for over 20 years. A little bit on my background. A supermarket contractor for over a decade. Wholesaler. Business owner. So I've been around for, you can tell by the gray mustache, a long time. And I'd like to keep this presentation a little bit casual. So if you've got questions, I don't know how you want to handle that, James, but we can handle questions as we go. I won't really be able to see anything typed in. I can't concentrate that hard. So if you want to verbalize some questions, great.
I can do that for you. Anything comes in typed, I'll go ahead and let you know.
Yeah, okay. I'm trying to advance my slides here. The reason we're going to be talking about A2Ls is because of regulatory issues. Now, I'm going to focus on mainly federal because I do this presentation across a lot of states. And I know things are a little different there in California. You're ahead of the curve. I'm from New York. We're trying to catch up with some really drastic regulatory proposals out there. But anyways, we'll concentrate on the federal, and then we can handle other questions as we come. So under the AIM Act, and after the U.S. had signed on to the Kigali Agreement, the EPA was given authority to actually begin to regulate on GWP or global warming potential, that sort of thing. So they've established a 15-year phase down on HFCs to get to a predetermined level, which is going to be 15% of what the industry used to use in 2011, 2013. Now, the growth of HFCs from that time frame has really been a lot stronger. So what that means is that if we're held to those levels, it's going to be a pretty tough supply issue going forward. But that's where we are. They also, in addition to phasing down our production, it can authorize sector-specific prohibitions. Excuse me. That could be individual uses, and they can establish a time and a GWP requirement. And lastly, they want to get serious about reclaim and recovery. And some of that is in the proposal phase, but they really want to push, and you'll see why, because they want to build reclaim into the supply channel. In California, you're probably already seeing some of that. Here's what the phase down looks like. I'm going to try to, I'm missing half my slides because I'm looking at, there we go. I had some video on the side.
Hey, partner, can I interrupt real quick? Can you guys mute your microphones? We're getting an echo. Is anybody else getting an echo?
Yeah, I was.
Yeah, I was as well.
Okay. So here's a look at the phase down. And I mentioned that time frame. So we're into a in 2024 down to 60% of the supply. And to explain this a little further, this just isn't pounds of refrigerant. What this is CO2e equivalent. So suppliers like Honeywell or importers were given allotments of refrigerant in CO2e. So what that means to probably everyone on the phone is, if Honeywell wants to take their entire allotment and make 404 or 507, then it chews into our basket really quickly. So it's a business decision, right? We also make YF for automobiles. We make 448, some others, some new A2Ls coming out, which I'll cover. So the lower GWP products that we manufacture, the more pounds we can make, and we can stay in business and supply the industry. So if you're reading into that, what you'll see is that the supplies of 404, 507, any high GWP refrigerants will start to become scarce, because it's just not in our best interest to make them and sell them and chew into what we have. And that's going to accomplish what the EPA wants to do, and that is to remove high GWP products from commerce. So that's the thought. It's a model that they did in Europe, and they're following it here. And again, it's a phase down, not a phase out. We get a lot of questions. So are these totally gone? Because there are some HFCs in some of the HFO, HFC low GWP blends, but we'll have access to those, going forward.
Hey, Ron, real quick, if I can just interject with that.
Yeah, sure.
Put that a different way. So Honeywell's given, let's say, an allotment of a GWP value of 1,000.
Yeah.
So if they make a refrigerant that has a GWP rating of 500, they're allowed to make 2 pounds of it.
Correct.
If they have a refrigerant that has a GWP of 100, they can make 10 pounds of it.
Mm-hmm.
So they have an allotment, and so that's kind of what Ron's talking.
And doing a big forum.
That's exactly.
They have
That's exactly right.
And they have a home.
I got
and they're
someone
looking for someone to come out and do maintenance. I mean, do a bid for maintenance instead of calling up the company.
Somebody needs to mute their microphone.
Thanks,
Thank
Eric. And I mentioned you mentioned 1234 YF that we make for automobiles as a GWP of 1, right? We can make 1,000 pounds, to use Eric's analogy. And we've got other refrigerants used in as the chiller market, 1233 ZD that has a GWP slightly under 1. We can make 1,000 pounds. So you can see where this is all going. And I hope everyone understands. Thanks for interjecting, Eric. It was great. The EPA is all over us on record keeping and that sort of thing, and import. So they're watching it, and they've got some really stiff penalties in place. And the timing is right now we're in the second deal of it. Honeywell actually has the largest allotment in CO2e through 2028, and then they'll do it once again. Sector specific, I mentioned that they're going to phase the amount of HFCs down, and now to curtail some of their use, they can look at individual applications, anything from a walk-in cooler to an ice machine to cold storage to an ice rink, and they can assign values, GWP values, and when you have to make a move to something lower. And this is not only refrigeration equipment, air conditioning equipment, but the foam that's used in walk-in coolers, aerosols for propellants, all kinds of things would go against our hit. So it's not just refrigerants. And the federal guidelines only are concerned with new products and new systems. It does not affect installed equipment or retrofits, that sort of thing at this point in time. They believe that by, shortening up the supply of the higher GWP products, then that'll move down to retrofits, and then people will just replace equipment. And there's a transition dates for all of these vary a little bit, and I think I've got a chart coming up where we can see how that works. Before we jump into that, this is just an explanation of some terminologies that the EPA uses. And if it's a product under EPA language, it's a factory charged piece of equipment. The picture shows a a domestic refrigerator, but it could be a humidifier or a dehumidifier, et cetera, et cetera. So that's a product. A system is anything that you would put together in the field, split system, when a walk-in cooler or a supermarket or the rest of it, or even a residential. And a component is a major portion. So this is an example of residential. A condensing unit is a component. An evaporator would be a component, et cetera. That you just have to be aware of how the EPA is looking at things, because as they come up with more rules, they may say that, yeah, you can change a component, but you cannot change the whole system. For example, on the air conditioning phase down, going to 32 or 454, someone has wants to maintain their 410A unit and they lose a compressor. Under the federal rules anyways, you could buy a 410A condensing unit even after the rules go into effect. And you could buy an evaporator coil. What you cannot do is buy both and hook them up as a new system. That's the a rub for industry, because if we're transitioning away from, say, 410, if there's still 410A components out there or to be available, it could be an issue. The industry pushed back a little bit. Suppliers like Johnstone, everything, if they made this transition to January 1, and again, if I'm speaking to rules that are already in place in California, I apologize. I'm just not that familiar, but you had to be able to push through some of this inventory. So the EPA backed off, and they're giving a year so wholesalers and manufacturers can sell equipment that's got 410 in for another year to reduce inventory. And the industry is proposing to ban the manufacturing import of 410A condensing units and other components. The fear there is that offshore people will just keep making 410 and sending it in here for they call it a component for service, and it'll make its way into new installations. Not really sure how that is going to end up, but that's in the works. This slide is looking at new equipment segments, what the GWP range is being set, again, federal, what products are currently there, when it's going to happen, and what may you use going forward. So if we take a look at residential light commercial, there's a new level in place, which is 700. 410A, by the way, was a little over 2,000 GWP. So quite the drop down to 700. January 1, 2025. So federally, if you're installing something new, January 1, 2025, it's got to have a either 454B, and my apologies, I don't have R32 on the slide here, but you're going to see a split between 454B and 32. Those will be your compliant products. VRF, they've pushed it out a little bit to 2026. And I'm certain 32 will find its way there, along with 454B. And I don't really think I need to go through every one of these. The point I would like to make on this slide is, well, you've got, pretty hard reductions in GWP. A lot of the existing products are going away in 1, 2, or 3 years. There are substitutes on the far right. So really for every application the industry has developed, and it's not just Honeywell, there's others making things that mimic performance, such as the 454B and the 32, pretty much with your gauge sets, and the rest of it looks like 410A, and all through refrigeration, the same thing. There's a few new ones in here. If you're not familiar with, say, 515B, 513, a 134 replacement, et cetera, and a couple other very low GWP products, ZE and ZD, chiller work, 134 and lower, or R11 like in case of ZD. So there are products that are compliant that can get you under these levels, and in some cases a lot under. What you're going to see is that many of these solutions that are higher capacity, like 454B, or in the case of refrigeration, 454C and 455, they are now going to be what's called A2Ls. They are going to pick up some flammability. We've reached the limit of developing high capacity, medium pressure refrigerants that are A1, ASHRAE rated, non-flammable. And the reason for that is that the flame suppressant that we use in a lot of these refrigerants is 125, and it has a high GWP. So 32 is mildly flammable, for example. In the case of 410A, how do you make it non-flammable? You add 50% 125, and now you've got an A1 blend. Because we don't have access to 125, there's a search on for the last decade to find suitable flame suppressants. It's a tough thing, and the industry is to the point now where we need these replacements as soon as possible. And the A2L classification came into being. They're mildly flammable, safe to use, and we'll go through some of that.
Just real quick, Ron.
Yep.
Just so that everybody understands, the 125 is referring to 410A contains the 125.
Yep.
So it's not something new to us. It's just something we didn't realize we were using.
That's correct. That's correct. And if you look at all the 407s series, they're 32, 125, and 134A. So you've been using that refrigerant for a good
hard for me to do both.
Right. One other thing on the EPA's push, they really want to get focused on recovery, and some other things that they've put in place. These are proposed here that you're looking at the screen. In the past, if you had larger charge size and leaks, and in California, again, I don't want to plead too much ignorance, but on the federal level now, if you've got a GWP greater than 53 and you've got 15 pounds or greater, then you have to start following the leak protocol, record keeping, etc. It's proposed. That brings you into the realm of some rooftops, and the rest of it where typically in the past, grocery stores, cold storage had to do that kind of record keeping. They're trying to set a reclaim standard that if you've got, you cannot have more than 50% of virgin refrigerant in used reclaim, which is often done by the reclaimers. They bring things back and then they reconstitute the blend by using some virgin refrigerant. They're going to be restricted there. In 2028, some equipment that's factory built will have to use reclaimed HFC. The issue there is the industry doesn't know if there's going to be enough, especially if you get into lower GWP products, to satisfy that. Service and repair in 2028, you must use reclaimed refrigerant for service in standalone supermarkets, refrigerated transport, et cetera, et cetera. Again, the industry is pushing back because they don't believe that there is enough reclaimed refrigerant to satisfy that requirement. And the last one, they are trying to make disposable returnables, frankly, not disposable any longer. You'd have to bring your disposable cylinder back to Johnstone. They would have to package it up and then send it to a reclaimer to pull out any what we call, residual refrigerant or a heel. The issue I have with that is under 608, prior to disposing of cylinder, you're supposed to be pulling that to subatmospheric and recovering everything now. And the worry from industry is the cost, right? Someone's going to have to pick that up. If we're packaging these and sending it, to Johnstone, and Johnstone has to collect it from you, and then they've got to ship it by truck to a reclaimer, and then they've got to do that work. Someone's going to pay for all of that, and it's going to end up being the contractors and the end users. I bring it up again. This is proposed, and that last bullet point is a reaction to the fact that the EPA lost a lawsuit. They wanted to make everything returnable. They were sued, and they were told they didn't have the authority to regulate cylinders. So they had to back off, and this is their attempt to get what they want to accomplish. Again, this is proposed, and we'll see how it rolls out in the near future. So why A2Ls? I'm not going to read all these things on the slide, but I'd already mentioned that there's a lot of replacements. And the replacements that the industry, Honeywell and others, is able to come up with, they really mimic the A1 refrigerants. 454B and 32 mimic the performance of 410A in equipment. What that means to an OEM building equipment is they don't have to do much in the way of re-engineering. So in other words, someone's building a 410A unit and they're going to go to 454B. Most likely they don't need a different compressor. They don't need a different evaporator, condenser, line sizing, anything like that. They do have to accommodate the fact that it's got a mildly flammable, and they perhaps have to add a small leak detector, maybe another solenoid valve to isolate the charge, that kind of thing. But no major redesign on the parts and pieces that that they use to put something together. That's a simple explanation, but it's the same thing. Someone building condensing units for refrigeration. 454C, 455, they're actually a little bit more efficient than 404. Very similar flow rates, very similar compressor, line sizing, etc. So not a lot. So that's why the industry is really looking at moving in this A2L direction, because it's not much different. Question?
Hold on, Sophie.
Sorry, I had somebody could mute it, it'd be great. So bottom line, it's pretty easy for manufacturers of equipment to move into this stuff. And from a technician standpoint and the rest of it, you'll see as we move forward here, very similar pressures, temperatures, superheat, subcooling, all the same things we're used to doing. You're going to do with A2Ls, a little bit more emphasis on safety going forward because it is mildly flammable. But it can all be handled in a very safe manner. But it's the next step in refrigerants. Talking about flammability and how things are rated, and I'm hoping that my videos here will run, but this is just a chart on how ASHRAE breaks it down. And you can see historically we used A1, things like 448, 410, skip the 471 description, but for the 407 series, all those were A1s, 134 could be in there, etc. Low to no toxicity, non-flammable. Lower flammability, in fact, ASHRAE actually broke the classification. Previously, there was only A1, A2, and A3, but A2Ls were nowhere near the flammability even of an A2L. So the whole new classification is in place with different rules and standards applying to them. And there's some A2Ls listed there. 1234YF, if you're driving a newer vehicle, that's the refrigerant that's been in there for probably the last 8 years or so, maybe longer. That's an A2L. And then 454B will be a 410 replacement, and the other two refrigeration. And you kind of see where ammonia falls. They have toxicity. They're also a 2L. You've got to have the certain concentration in air to make these things burn. And then hydrocarbons like propane, isobutane, they're way up on the top. Now, there's other ways I could explain flammability. I can show you glass tubes that we run here in the lab, and we spark, and we show flame, and you measure the angles and all that sort of thing. But I think I can do something more practical. And the pictures on the right, and I'll try to make them run. I think I can. The bottom one, you're inside of a refrigerator. We developed a little sparking device. Basically, takes the evaporator fan power, through this little gap sparker, and we run it, and we leak to a 1234 YF, 111 grams in here. Now run the video, and you'll see what an A2L exposed to a spark looks like. Again, you're inside the refrigerator. That's the door on your left-hand side. That's the rubber gasket. And when this stuff does burn, and occasionally you have to watch close. There you go. I don't know if you saw the little puff. You got a bump in the door. So that ignition energy and flame speed are all the types of things that would be on a more technical basis. But this is exciting as an A2L can get, right? That's what'll occur if you get a spark. Whoop, makes me go back. Now the same experiment I'm going to run, and we use 55 grams of R600 isobutane in here, and you'll see in a minute why I could not show you the inside. Whoop, doesn't want me to run that video. There we go. That is 55 grams leaked into there, half as much as we ran with the YF. And that is a difference between an A2L and an A3. There are some that are pushing for larger charge sizes, commercial charge sizes of these hydrocarbons and residential air conditioning and the rest of it. But I hope that a couple of short videos demonstrates the difference. There's no comparison when you start talking about flammability. The ignition energy is so low on hydrocarbons that a static spark can get them to go. Everyone's familiar with, if you do something wrong on your barbecue, that kind of thing that can occur. I'm not saying it'll be a regular occurrence, but I hope that is a better demonstration of A1s or A2Ls and A3s. There's a couple definitions that all the way down to technician level, you're going to have to be aware of. And really the one that's going to be most common is LFL, lower flammability limit. The reason you're going to have to know that is because all of these A2Ls are going to be slightly different, and they will have a different LFL. Even if you're installing residential air conditioning, it'll come in the manufacturer's packages, we're assuming, on the startup instructions. And don't chuck that into the nearest trash can like probably everyone has done that you get so familiar doing things, because there's going to be some calculations you're going to have to be aware of. Some are developing apps and the rest of it. And what you want to make sure of is that you do not use a refrigerant or a system that has the ability to put more than is allowed if it leaks into a particular space. So it's going to have to do with the size of the space you're putting in, say, an air conditioning unit, or in a case of a refrigeration system, a walk-in cooler, that sort of thing, and be aware of it. And I don't want to go too much into the rest of it, but LFL will be important, and all refrigerants will have their own. So don't assume that if you're using one 404 replacement and it's an A2L, you can retrofit to another one, because someone may have gone to the max charge, and by making a switch, you could be over the allowed charge size. So more to come on that. The manufacturers, I think, are gearing up to do a good job on what's going to be required.
Hey, Ron, real quick, I just want to backtrack just for a second.
Sure.
Because I know that there's probably a few people that saw that refrigerator explode and are in a little bit of a panic.
Yeah.
Hydrocarbon refrigerant, R290, which is propane, 600A, what he showed also on that refrigerator, isobutane. and Ron, you can correct me if I got my numbers wrong, but I believe the EPA has limited the charge on those to 5.3 ounces. So we're
Yeah,
not
that's
going
it. Yeah, right.
we're not going to see those in conventional air conditioning systems. And I warn people because you can go on YouTube and you can see videos, and there's a couple of guys walking up smoking a cigarette on a ductless system and blowing up. Outside the US, they are allowing those hydrocarbons to be used on ductless systems and such. In the
Right.
US, it will not be allowed.
I'm glad you said that, but there is a push by many to increase the charge sizes.
Yes, yes.
Right.
But
So
but
go ahead.
as of right now, I think it's 5.3 ounces. That's why I was asking for you to clarify, because I know you probably have a little bit more up-to-date information
Yeah.
than I have.
Yeah. Yeah.
Yeah.
500 grams, I think is the max.
Yeah.
And some are pushing for higher, but we'll see how that goes. But you're absolutely right. In the US, that's the limit. And it's unrelated story, but I travel a lot, and I was in Canada. I was in one of their it's Canadian Tire stores, and I was walking to the automotive thing, killing time between appointments. And there's a do-it-yourself homeowner refrigerant recharge kit with a hose and a gauge, and it was isobutane, and the instructions said that you could top off your R22 air conditioner. And I got diving into it, and there was no rule in Canada that prohibited that. So you got homeowners putting a hydrocarbon into R22 residential systems. That's just disaster in the making. You know, if you're a tech following up behind that, you don't know. That kind of thing is bad. But other countries, there are things that happen that most likely won't happen here. And if they do, the first time there's a major accident, they'll probably resend it. But we'll see where it goes. Things are developing. Thanks for chiming in on that.
You bet.
A2Ls, there's a lot of them that are already in the marketplace. I don't want to spend a lot of time on this slide. Just talks about, similar to the other slides, some different segments and what's going to end up over there. The only point I want to make is in the chiller segment, product you may not be aware of, 1234ZE. It is an A2L, less than one. It's really finding its way into chillers, reciprocating type chillers. You can't go to an ASHRAE show without seeing that refrigerant in chillers, and it's finding its way, and it makes sense. Less than one, medium pressure. It's a 134 lake refrigerant. Should be around forever, and a really good application there. In fact, you look at these chillers and you think air conditioning. We did a job over in Europe, a cold storage using a chiller, and the compressors were able to deliver 14-degree Fahrenheit glycol, which is sufficient enough to do a medium temperature cold storage. So, not good for companies like Honeywell because chillers don't use a lot of refrigerant. But if you think of it, good for the environment, less than one, nicely built chiller. The economics of the project were great, and the performance has been excellent. So you're going to start seeing some innovative uses of refrigerants that you wouldn't have thought into the refrigeration market through the use of chillers and the rest of it. But every segment's going to be touched, and most of them are going to move to A2Ls. Now, when we introduce a refrigerant, the timeline on the bottom is how it used to go. We would develop something based on a reg or something we innovated, and we would take this refrigerant, test it in our labs. Then we would send it to ASHRAE standard 34 to verify what we know about it, non-toxic, non-flammable, all the other characteristics. And then once it was done in ASHRAE 34, if you're going to use it, it would go to ASHRAE standard 15, which is a safety classifications for using it in equipment, and they would write regs around it. Then it would find its way to the national and international building codes. You can see the time frame there. And then by the time this new refrigerant hits local building codes, it could be as long as 6 to 8 years away. What's happening today is because the EPA, CARB, et cetera, are being so aggressive and their timelines that bringing refrigerant that's compliant to market now is trying, we're trying to get it done in a year. What used to take 6 to 8 years, trying to get it done in a year. And it's almost impossible because one thing is not here. We develop a refrigerant, and along with submitting it to ASHRAE 34, we have to submit it to the federal government under what they call their SNAP program, Significant New Alternative Program. So I think it means, and then they do their analysis. It's not only safety, so they'll take things from ASHRAE and the rest of it, and then they'll ask us for financial stuff. Where markets is it going to go into? Oh, it's a real pain. It takes them sometimes a year just to call us back on our application. We've got some applications that have been in the SNAP office for 3 years. So by the time we get it back from them, then of course we have to go to OEMs, we have to do trials and the rest of it. So we're up against it because these rules for under 150, et cetera, are, as near as January 1, 2025, and some of this work is not done. And to complicate it, or not complicate it, but to get them into commerce, local building codes, some states have elected to actually jump ahead of their own codes people and vote on it in a legislature because they want to be green. So, right. So they're just saying you can use these A2Ls in our state. Now that doesn't help out the building code people or the industry. What does that mean? They say if it's SNAP approved, you can use it. So you can imagine when you go to, install it and you got a building inspector that never even heard of the refrigerant. So HRI has jumped in. They created this map, and you can click on a particular state, and they'll give you the status of A2Ls in their state, which will help. And one thing I didn't really mention is that if you're making equipment, one thing is to have the other approvals, but you have to sell listed equipment. That is UL listed or ETL listed equipment. Those standards are being revised as we speak. UL 2-40 is just about done, and that is under air conditioning. So that's moving faster, and equipment suppliers are going to be selling A2L equipment, now, basically. I think you can take orders for it. 2-89 deals with the refrigeration side of things, and that's a little bit slower. They published something, and now there's a big debate about charge sizes and releasable charge. So it's a little bit complicated, but this chart should help if you're going to do an A2L installation, find out what that state status is. And if you run into issues with a building inspector, you can reach out to us at Honeywell. We do have consultants that can help walk the project through. So there's going to be a lot of that just because of this fast pace of commercialization of these A2Ls. Hopefully it'll become, more common in the near future, but it's a little bit of a challenge at this point in time. I want to talk a little bit, and I mentioned this about the LFL. I'm not going to go into this whole thing, but refrigerants have a range of flammability, and I mentioned LFL, the lower flame limit. And in the charts you're going to get from some manufacturers, there's going to be a formula. They'll probably have a table in there. And M1 basically would be a massive refrigerant that you can use based on a room size. Typically, like a 3-ton residential air conditioning unit will be M1, and you won't have to do anything. M2, where you start to actually have a smaller size, or you have other flame possibilities, and it's all going to be written out in the standards and in the literature. You just multiply it by a different number, so it gives you more restrictions, or you can go, a larger charge if you've got isolation valves, leak detection, ventilation, all that sort of thing. So you can see it's going to be a little complicated, but what I do want to point out is that these refrigerants are different. And if you look at the chart on the top right, propane, we talked about it. The max charge here, in fact, this is an update, Eric, you brought it up, with LFL, 1.1 pounds. Now, I'm not sure where that even would be applied, but you can see the difference versus 454, 454C, and 455. anywhere from 200 up to 250 pounds you could use based on the LFL. And if you start what I mentioned earlier, be careful of what you're doing, because let's say you build a system, a small supermarket system or a distributed rack with 455, and you're using 247 pounds, the max. And in a year you lose a charge or something, you grab a tank of 454C. If you put 247 pounds of 454C in there, you would be out of compliance because its max would be 166. So I know this is a little coming at you a little fast and it seems complicated, but in talking to the OEMs, their literature, maybe even apps, will be a little bit clearer on what you can use and where you can use it. But it's worth keeping in mind because things happen. You're in the HVAC business and you do a lot of light commercial, residential. You get called to some place that's got a little computer room, and you've been putting 3-ton units in homes on a regular basis. There's a lot of volume in a home, typical home. Now you've got that 3-ton unit and you want to hook it up to a small little computer room that's 10 by 10. Well, most likely you are going to be out of compliance because of that small space. Now you need 3 ton because it's got a high heat load with the computers. So you see where I'm going there. You have to be aware of what you're doing and what you're using and make sure that you're compliant. And this type of thing will fall back onto the installing contractor, to be aware of it and to do the right thing.
I just want to chime in real quick, Ron. 2 things.
Yep.
One, I just want everybody to understand, and hopefully you're seeing, this is not like when we transitioned from 22 to 410A. There's a lot more to this. So please get your training. I mean, this is great what Ron's presenting, but understand there's still more, and Ron can verify this. The stuff is still changing. The second thing I just want to chime in on, Ron keeps talking about, how it's coming fast, and it is. It's coming hard and fast. The Kigali agreement that he referred to was, I think, signed in 2017. Does that sound right, Ron?
Yeah, 17 or 18, yeah.
Yeah. And so the rest of the world kind of started moving on this. The U.S. didn't. And so now that we have it in place, the U.S. is now trying to play catch up. California is actually taking one of the lead roles in that, and the EPA is actually looking at what California is doing and looking at adopting that. In fact, with the GWP, California had said, we're going to go to 750 when the EPA was talking about 1500. And then the EPA decided, no, we're going to go to 700. And that happened last October. And so, yeah, so it is coming at us very hard and fast, and it will continue to come at us hard and fast. And unfortunately, it's going to continue to change as we move forward as well.
Yep, that's a fact. Little bit about servicing and transporting. What I was saying about performance, very similar to A1 systems. That being said, there has to be more of a focus on safety because of the A2L classifications. And I'm not going to go through all of this, but what I do want to get across is there's good service practices that we should all follow that have been in place for a long time. Unfortunately, the more familiar you get with doing this work, whether it's just air conditioning, refrigeration, we start to take shortcuts, right? We're in a hurry, so we don't run nitrogen through the lines when we're brazing. We don't pull down to the designated vacuum level. Business dictates we do everything fast and get in and get out, right? This is a good time to go back to best practices, right? You may or may not be aware of the fact that when you charge a refrigerant, even an A1, into a system, it could be 410A, the lubricant that you're using is what's called miscible. That means that the refrigerant and the oil like to mix. So if you charge a system, some of the refrigerant ends up in the lubricant, and it will be the same with A2Ls. Now you've got, a flammable component. So you break open a system, you do a quick vacuum, and now you're going to start brazing on it. Well, if the oil can, as the temperature goes up, can start to outgas and basically release the refrigerant. Not a huge deal in and an A1 refrigerant. On the other hand, I have started R22 and mineral oil on fire. So it's going to be exacerbated by an A2L. So if it calls for a vacuum level, attain it, purge, with nitrogen, and be aware of what you're doing here. Use equipment that is specified for A2Ls. It's all out there. I've been surveying all the manufacturers. I'm sure Johnstone's got it in stock. In servicing this equipment, use only original OEM components. The aftermarket may catch up, but at this point in time, everything on the units, they'll have to make it intrinsically safe. They'll put it in different types of enclosures. So, only use OEM parts at this point in time. There is a requirement for the people building the equipment to provide detailed service installation guidelines. I mentioned that earlier. Read them and perhaps leave it for the next servicing contractor, right? So that they're totally aware of what you've done and how you've charged the equipment. This is just a little bit more on servicing. Use inert gas, I'd already mentioned. There may be some rules in place that you have to vent your vacuum pump to a safe location away from where you're working. Again, leak checking, create a service log, and all I can really say is follow the OEM's guidelines. They're going through all of this stuff with UL and the rest of it. So do it right, do it safe. And if they call for example, triple evacuation before you do something, then just follow the rules. And everyone's going to have to do the same thing. Couple things about, I find this interesting. The equipment that's going to be built, and everyone that I've surveyed from an OEM standpoint are going to use the same equipment connections that you've seen on everything else you've always worked on, 1/4-inch male flare, etc. They have to paint them red. Otherwise, they are the same connections, right? This is a guideline, by HRI. They've been pretty involved. So from our knowledge, all the OEMs are just following this guideline. Now the cylinders are different. The guideline is to go to left-handed threads. That'll be both on the disposables and on the returnable cylinders. Honeywell is going to follow their recommendations, but don't really sweat it. All the aftermarket companies have already made adapters for the cylinders to get you over to if you're used to using 1/4-inch flare hoses, etc. It's all, in the works, and you'll be able to buy those adapters. But I find it interesting that, you can say right hand on the equipment you're servicing, but you had to go left hand on the cylinders, but it is what it is. And Honeywell is going to follow that, as I said, the guidelines as close as we can. Transporting. There's a lot in flux here. Basically, transport these cylinders like any other flammable gas. There's requirements for vans under DOT, how many pounds you can carry, that sort of thing. I won't go into it here. I heard you mentioned ESCO training. They go into really, really depth there on what you need to do. Initially, they wanted everything shipped in an upright position. There appears to be some relaxation on that. There's been an exemption. I don't know how or where we are in obtaining that exemption, but we did get some information that those semi-horizontal racks and service vans should be okay if you position the relief valve on these new cylinders, the disposables, up in the 12 o'clock position. There's more to come on that sort of thing. Let's see.
Just real quick, Ron, and I don't think we've covered this yet. Our traditional refrigerant tanks, our A1 tanks, had a rupture disc on them.
Correct.
Right? So pressurization. The A2L tanks will actually have a pressure relief valve. That rupture disc is gone. And so that's what he's referring to. That relief valve has to be in contact with the vapor space. So that's why they originally said upright. But now they're saying basically if you can position the tank in that 45-degree bottle rack so and you make sure that pressure relief is on the vapor space, then we should be okay. I don't know if that's official yet, but that's seems like where it's going.
That seems like where it's going, Eric. That's correct. And we keep trying to get as much as we can from, Department of Transportation. But I do know that Jason at ESCO is all over it, and he can supply documentation, I believe. But that's our understanding. We're still in the mix of figuring out our 100-pound cylinders. On whether or not we have to ship those upright. I do know that one company got an exemption. We think we can get onto it, but it'll be a problem for us if we have to ship all of our code 10s upright. We'd have to put them in basically caged pallets and that sort of thing. But we're working on it. One other thing.
I was just going to point out real quick too, Ron, is please note that this top bullet point here says, A2Ls must be transported in the same manner as other flammable gases. We're not talking about A1s, right? They have to be transported as same as flammable gases.
That's correct. Mm-hmm. Interesting. And Eric and team, you guys can check on this. I'd heard recently that based on the amount of pounds you can carry under the DOT as a service, I think they call it something of trade. You're allowed so many pounds of flammables, right? That would be your settling and all that sort of thing. Now A2Ls will go into that, and I think there's a limit, and that limit may exclude carrying a code 210 cylinder in a service van. Something to look into. I just heard it the end of last week, so I've got to dive into that. Just to somebody take a note on that.
Yeah, that is one of our fears here in California right now, as all the DOT, California Fire Code, Mechanical Code are all being changed because of A2Ls. That is one of our fears right now, is we're going to have this limitation.
Yeah. So a code 210 laying on its belly in the back of a service van may not be good to go under even federal DOT. Got to figure that out.
Yeah.
Right. Refrigerant storage. I'm not an expert on this, but if you're going to have a lot of refrigerant storage, even A1s, there are restrictions on refrigerant storage now. The best guideline that we can give you is to, and I know everyone hates to bring an inspector into your business, but you need to be safe. OSHA, get your local inspector. HRI is putting some guidelines out. It's pretty substantial on what you can store, but you need to be clear on, does it have to be in a caged area or open air? Is your building sprinklered, ventilated? Then there's differences on how much refrigerant you can keep in stock. This is probably more for John Stone to worry about than a wholesaler, than a contractor. But it's something to take a look at. Have things placarded, and even for the contractors listening, every refrigerant that you have, you should have an SDS with you in your service van, that sort of thing. And then if you've got a facility with a lot of refrigerant, if there's any permits you need, make sure that you have them. Reach out to the authority having jurisdiction and make sure that you're compliant. You don't want to get, in trouble, which equals generally money and problems. So be ahead of it.
Ron, real quick, we had a question in the chat. What are the conditions for the relief valve to release pressure?
You're stretching my memory now. That's under the old ARI guidelines. It's the reference point is 130 degrees. Boy, I'd have to dive back into it, but it's available on ARI. It's the same as a recovery cylinder classification, but I'd have to dig it up. There's relief, and then there's burst pressure, and it's so many degrees above the that 130 that it has to maintain a certain pressure. Apologize, I can't answer it on the fly. I'd have to get, my memory's not that good anymore. I'd have to go back and look it up. But I can do that after this call, and then we can supply the answer to whoever's asked.
Absolutely. And we'll get that out to you, Jeremy and Troy.
Yeah. Great question. I used to know it because back in doing a lot of tech service, but we'll find it. And there were a lot of questions when 410A first came out around that sort of thing. So it'll be similar, but we can get you a definitive answer.
And just real quick, Ron, for as far as the storage, for the contractors out there, the only place you probably need to be concerned if you're an organization that buys, at the beginning of summer, pallets of refrigerant and you have a small shop, you're going to want to do some double checking to make sure you're still in compliance doing that. Because there is, the amount of refrigerant can only occupy, you have to have a certain amount of cubic footage for it to occupy.
That's right.
And so we're not 100% clear on where those numbers are yet. But stay tuned, and as soon as we have that, we will get it to y'all.
Yeah, Eric, and it looks like you're in contact with Jason at ESCO. He just got something last week, I think, on that. And I want to say 20,000 pounds or something. But anyways, he's got a more current values that I'm sure he'll share.
Okay, great. And that just ties in what Ron and I have talked about, right? This is ongoing, and unfortunately, it's still changing as we go.
Yeah, it certainly is.
Gentlemen, have they made any particular notes on the updates yet with regards to particulate sensors and exhaust fans for dispersal rate in a given space?
ASHRAE standard 15 is handling that. There have been some updates. I'm not an expert of what they're doing, but the current work is accommodating the A2Ls. The only thing I do know is that the ventilation requirements, if you're talking about an equipment room or maybe even storage, they have finalized some of the formula for those ventilation rates. And as far as the leak detectors go, the only thing that I'm familiar with is equipment mounted that has to go off on 25% of the LFL. They seem to have the OEMs conquered that with some reasonably priced detectors, but that's about as far as I can go on the subject.
Okay.
You could ping me. After my emails, I think at the end of here, and I can dive a little bit deeper if you need me to.
That would be a good idea because I think most of these contractors would be very interested to find out, if a manufacturer is going to produce a wall mount like the CO2 wall mounts we use on common equipment for their shops, by which they can have an exhaust fan kick on a dispersion rate based on parts per million and eliminate a potential problem with or without an inspector involved.
Yeah, that's great. And here's a question that came up. I was doing a seminar last week, and a lot of the leak detection equipment is really good these days, even wall mounted stuff. But with an A2L, you have to do something at 25% of the LFL. So pretty low, right? Then the issue is, how specific can it be? Like right now, you buy a general, we use them in the lab, and pretty much any HFC or HFO it'll pick up. Now, if the requirements in a warehouse that's pretty easy, right? Let's say an A1 leaks and it picks it up, you turn the fans on, it's not the end of the world. If it's an A2L, and we're talking now where you've got working equipment like an equipment room, the requirement could be that you need to shut down equipment, right? Close solenoid valves, that sort of thing. So again, like Eric said, a lot of stuff is in transition. If you've got two pieces of equipment, one's A1 and one's A2L, and it's the A1 that's leaking and the leak detector is general, it could just start shutting everything down, even though you have no problem with the A2L. So I don't want to give the impression that it's horrible, but that type of thing is still being worked through. But if it is specific to A2Ls, what I'm being told on the equipment mounted leak detection, that it is specific to that A2L. So if you're going to use 454B, it'll be specific to that. And if you're going to use 32, it'll be specific to 32. Now, I don't know how they're getting that accurate, but that's what we're hearing. So it gets complicated a little bit in the warehousing. Maybe I'm overcomplicating it. You have a leak, turn the fans on, no big deal. Go find out what's leaking. In equipment rooms could be more of a complication. Supermarket, that kind of thing, where where you may have to start shutting down more systems. But if you can pose the question and get it to me by email, then if I can't answer it, the folks here in the lab can.
And Ken,
Get your
I don't
response.
know, Ken, if you can see this, I just got a 454 A2L monitor from JCI. As you can see, I haven't had a chance to play with it yet, but I plan to here very soon, and we'll be playing with it and testing it.
Very
I'd
good.
love to see the results of that, my friend. I really would. Because I'm already
Excellent.
beginning to quote 454B into the marketplace because of the timeline they're playing with on production in August, September, and October. So I'm naturally going to start getting hit with a lot of this at the commercial level where people are concerned about dispersion rates, etc. So if you gentlemen
bet.
can keep me posted on that, that would be deeply appreciated.
You bet.
Excellent. Good questions. This slide that you've got up here, talking about commercial refrigeration first, just showing you the differences. We're going to offer 455A, 454C, and 454A, all available from us. I don't have 455A on the chart here. Really, really good replacement. The GWP is up around 300. So these two are under 150. They're very similar in performance. And you might say, well, why would Honeywell supply both? Remember our conversation about charge size? 455A allows you the largest charge size. So a lot of the input we got from supermarkets, et cetera, is, they want the highest charge they can get to put into like a little distributed rack, that kind of thing. And they'll do whatever they can to get the charge as high as they can and have it do more of a lineup. So that's why we're going to offer both. Very similar in performance. And you'll notice that pretty much all of these solutions are more efficient than 404. 404 is a good refrigerant, low glide, low discharge temp, all those sort of things, but it wasn't the most efficient refrigerant. So, energy use is going to be, pretty good with these. We're going to ship this product in 25-pound cylinders, 100-pound, half-ton cylinders, and 1-ton cylinders. But really, LFLs are there. You can see a difference between 455 and 454C. That's why you get a charge size difference. But pretty much every application where you use 404, the rest of it, you're going to see these 2 or 3 refrigerants find a home. 454B, I'll just go right past this. This is going to be the Honeywell's main offering. We do not sell straight 32. I know Johnstone handles both 454B and 32, but we will supply 454B in 20-pound cylinders, a little different than the refrigeration, 100 pounds, half-ton tanks, ton tanks, etc. A lot of people ask about this in air conditioning. How different is 454B going to be to 410? So I just plotted the average operating pressures, across the whole temperature range, and you can see that they're very similar. 454B having a slightly lower operating pressure, not by much, but it will not be a lot different servicing this from a pressure, superheat, subcooling standpoint. Your gauges will be, you'll be familiar with the equipment that if you had familiarity with 410A. A little bit more on the air conditioning replacements. This is how they perform. 410A, and you've got 454B and 32. The flow rates are a little bit less than 410A. One thing I will point out when you take a look at outlet, the one issue with 32 is the higher discharge temperatures. You need to be aware of that. This is at 110 condensing, so you can expect some fairly high discharge. And I know a lot of the units accommodated by either liquid injection or the inverter slowing the compressor down, but I just do want you to be aware of something there. Other than that, they perform like 410A. 410A, as we mentioned earlier, is 50% 32. So that's brings you to high pressure and the high temp, high discharge temp. And you can see the GWPs over there. My only concern with the maybe with the 32. And I'm not trying to do a sales job on 454B, just give you realities. Everyone knows that the environmentalists would like to keep lowering the, the values on where you can use and what. And currently it's 700 and R32 is just squeaking under it. If the EPA was to adopt a different IPCC release, and it would change that and shove 32 over the 700. Don't know if it's going to happen, but I just want to put that kind of information out for you.
Ron,
Everyone, yeah.
Real quick, I just wanted to ask, how much more do you have? We're a little over our time now. I just want to make sure everybody kind of has an idea of where we're going.
I think
We do have a raffle, so that if you guys can stick around, we encourage you to.
Yeah, this is my last slide. A lot of resources. I've made this this presentation available to the Johnstone folks. You probably have your own resources, but they're all good ones. There's a lot more to learn out there. There's the book from ESCO. I mean, I heard you talk about it. It's excellent. We have you go to our site. There's a lot of things, including white papers on A2Ls. And perfect timing to ask me. Thank you very much for listening in. I thought my email was at the end, but it's ronald.vogl@honeywell.com. The Johnstone team knows how to get a hold of me. Feel free to use that and get to me if you've got questions. And thanks for listening, and thanks to Johnstone for the opportunity to talk to you. Appreciate it.
Thank
Thank
you, Ron.
you very
Appreciate
much,
your
Ron.
time.
Thank you, Ron.
You bet, guys.
Genuinely appreciate it.
You bet.
All right. So again, just want to let you guys know we absolutely can support you on this. Again, you guys got Ron's email address. He gave it to you there. If anybody has issues trying to get to it or didn't get that written down, you can always reach out to me at the training center or Eric Dillon at the training center. We're both available. Eric Rowan, do you have some stuff to give away?
I do. All right. So for the free A2L class, I have Mike Camper. You will be receiving the free A2L class. And then for the camping barbecue, that will be David Kurtzer. So I'll be reaching out to both of you to coordinate that. So thank you everybody for coming today.
Genuinely appreciate it, everybody. This will be up and posted on the Training Center's YouTube channel in the next day or so. So if you do want to review it, you're going to be able to do that. I did see that somebody was asking if we can get the slides out to you in a PDF format. Ron, that's not a problem, correct? Oh, you're muted.
That'd be fine as long as it's a PDF.
Got it. Yeah, we'll do it. If anybody's reaching out, looking for those, reach out to us. We can get you a PDF copy of those so that you'll have them on your own. And like I said, we'll have the entire webinar up on our YouTube channel in the next couple of days.
Yeah.
So
and I just put my email in the chat. If
perfect. So
Mm-hmm.
I'm going to give everybody a chance to jump over and grab that email from the chat if they need to. Again, if you have any other questions, don't hesitate to give us a call. We're going to be doing one of these about once a month until the feds actually decide what they want to do. And we can stop saying things like, well, we think it's moving this direction and it looks like it's trending this way. So whenever the federal government decides to make a decision on things, we'll actually get all that stuff. But yeah, over the next couple of months, look for more of these webinars. We're going to bring in some equipment manufacturers, some tool manufacturers to kind of give you guys a 360-degree view of everything that's coming. But for now, I want to thank everybody, and we will talk to you soon. Thanks much.
Thank you again, Ron.
Take
You
care.
bet. Thanks, everyone.
Thank you.